In this video, we're going to learn about logarithms. So first, let's try to figure out what is a logarithm. We'll start by looking at this equation, y equals 2 to the x power. If we make an xy chart, we'll check things out here and you see, let's start with 2 to the 0 power. If we plug 0 in for x, 2 to the 0 power is 1. Anything to the 0 power is 1. If we plug in a 1, 2 to the first power is 2. If we plug in a 2 for x, 2 to the second power is 4. And we're okay with negative values too. If we plug in negative 1 for x, 2 to the negative 1 power is 1/2. Remember, negative exponents push us across a fraction bar. And then we plug in negative 2, 2 to the negative 2 power is 1/4. Well, let's invert x and y. We've learned about inverse relations before. We'll take all the x and y values and switch them up. And let's graph what happens. The blue graph matches this chart. When x is negative 2, y is about 1/4. When x is negative 1, well, it's exactly 1/4. You can look at the graph, y is 1/2. When x is 0, y is 1. When x is 1, y is 2. When x is 2, y is 4. And you get this exponential growth. You know, when x is 3, y is going to be 8. It's going to keep skyrocketing. But when we invert it, we get this over here on the other side. When x is 1/4, which is about there, y is negative 2. When x is 1/2, y is negative 1. When x is 1, y is 0. When x is 2, y is 1. When x is 4, y is 2. If we were to keep going, when x is 8, y is 3. And these are inverse relations, and you notice they are symmetrical with y equals x. We've learned about that before. So something special is going on here when we invert this exponential function. And the inverse of an exponent function is a logarithm function. The output of a logarithm is an exponent. Try to keep that in mind. We're going to see 3 parts to a logarithm, and the output is an exponent. That's what all these y values are here. They're exponents. All right. We'll use that now to see what's going on with the parts of a logarithm. Again, the output of a logarithm is an exponent. So this 3 is an exponent. The base is 2. We write the base a little lower than everything else. It's kind of a subscript. You notice the log, the 8, and the 3 are on one line, and the 2 is just a little lower. The base here is 2. The third part of a logarithm is what you get when you take the base to the exponent. 2 to the third power is 8. Once again, here's the base, 2, and the result here, the output is an exponent, to the third power is 8. So now we know the 3 parts of a logarithm. We can put it in exponential form if we need to. The base is 2, so I'll start with that. Next, I'll grab the exponent. It's over here, the 3. And then what that base to the exponent equals is 8. So the base, the exponent power, and what it's going to equal. That's the pattern we have. When we have a logarithm, and we just write log, short for log, and log of this base, there's the exponent and there's the result. So we would really say this log base 2 of 8 equals 3. That's one way to say it. That's how a lot of people say it. Log base 2 of 8 is 3. That means 2 to the third power is 8. And if you're writing notes, that might be something you want to write. Pause the video and write those 2 things down. That's the pattern we're looking at today. Let's try another one. Log base 6 of 36 is 2. What's the base? What's the exponent? And the answer to that. We'll start with the base. It's 6. Next, the exponent is 2. And then it's going to equal 36. Not a surprise. 6 squared is 36. That's what we would expect. Now, you try this one. Don't worry about the negative values in the fractions. Just follow the same pattern. Go ahead and pause the video if you want and write that logarithm in exponential form following the same pattern we've already seen. And there's the result. There's the base, there's the exponent, and what it comes together to equal. So log base 5 of 1 over 125 is negative 3. That's the same thing as 5 to the negative 3 power equals 1 over 125. Try this one without any colors or arrows to help you out. Pause the video and write this in exponential form. What's the base, what's the exponent, and what's it equal? That's what you get. Here's the base, 10. The exponent is 4. And that's going to come together to give you 10,000. Because 10 to the 4th power is 10,000. Let's go the other way. We'll take exponent form and turn it into logarithm form, following the same pattern. So we have 3 to the 4th power equals 81. This is the pattern we have for the 3 parts of a logarithm. There's the base, there's the exponent, and what the base to the exponent power equals. Well, our base is 3. Up here, here's the base, there's the exponent, and what it comes together to equal. So our base is 3. The output of a logarithm is an exponent. So this 4 has got to come to this spot. And then 3 to the 4th power is 81. That's what's going to go right there. So log base 3 of 81 is 4. Or log base 3 of 81 equals 4. Let's try another one. Ooh, we got a negative exponent and a fraction, which is not a surprise because 2 to the negative 5th power is 1 over 32. The negative exponent pushes us across the fraction bar, and 2 to the 5th power is 32. But we want to write this as a logarithm. Here's our pattern. The base goes down here. The result of a logarithm is an exponent, or the output of a logarithm is an exponent, and then what the base to the exponent power equals goes there. Our base is 2. So I'll put it here. Again, a little lower than everything else. Our exponent is negative 5. That's what the output of a logarithm is. And then 2 to the negative 5th power is 1 over 32. That's going to go there. So log base 2 of 1 over 32 equals negative 5. Now, you try this one. Pause the video and see if you can write this from exponent form and convert it into logarithm form. There's the pattern, and there's the result. There's the base, there's the exponent, and what the base to the exponent power equals. Try another one without any colors. This has fractions and radicals. Don't worry about it. Follow the exact same pattern we've been doing and see how it goes. You can go ahead and pause the video and give it a shot. There's our pattern. The base is 5, the exponent is 3 halves, and it comes together to equal 5 square root of 5. So we just fill in those spots. 5 to the 3 halves power is 5 square root of 5. So log base 5 of 5 square root of 5 is 3 halves. This is the key to everything that we've seen today. So again, if you're writing something in your notes, that would be what you write. And our focus today is just rewriting from exponent form to logarithm form and logarithm form to exponent form, making sure we know what those 3 parts are. There's really no calculating to do today. It's just learning these parts of logarithms.